So interfaces are kind of an abstract concept in a way. They're concrete when you program with them, but really understanding what they are and how to use them is the more intricate, complicated side of using them. Have either one of you used programming interfaces before? All right. So let me walk you through the mechanics, let you see that, and then I'll start to talk a little bit more detail about, okay, what are they for? What are they good for, kind of a thing. All right, so this is just a console application, nothing fancy. What I'll do is right-click on the project, go Add, and I'm going to add a new item. And then right underneath Class is Interface. Now, the naming notation for an interface is to always start it with the capital letter I, followed by the name of the interface. And it's more of a visual representation or identification to say this is an interface. So classes are usually just a name, interfaces are I, and the name. So the sample I'm going to use for this lecture is the idea of writing the software end of a universal remote control. Okay? So I'm going to call this I universal remote. Okay. Now the template that Visual Studio gets you or gives you should look pretty reminiscent, similar to what you see when you're building a class. The only real difference is the keyword interface versus the keyword class. I'm going to go ahead and make this public. Now, an interface can hold two different elements. You can define methods, and you can define properties. And what an interface is supposed to do for you is to act as a blueprint for a class. Okay? So, again, I'm going to kind of go through these mechanics, but let's say that this universal remote, what does a remote control need to be able to do? It needs to be able to perform certain actions, such as we'll do public void volume up, void volume down, public void power on, public void power off. So these are methods that I'm defining. Void channel up, public void channel down. Okay? So now you'll notice with the interface definition that unlike a class, I'm not actually giving these methods any sort of body. There's no curly brackets after the parentheses. It's just a semicolon. The interface is, just as I said, it's a blueprint. It is the construct that a class must implement. So if a class implements this interface, notice I'm using the word implement. It's different than saying it inherits. When a class implements this interface, the class is basically set into a contract that's saying, I will implement any methods and properties that are defined by this interface. So if I go in and I right click on my project, I'm going to add a new class, and I'll just call this an LG TV remote. Okay? So what I'm going to do is I'm going to implement the I universal remote interface in this class, which means that the LG TV remote is going to comply with the blueprint that's set out by the universal remote interface. Now, the nice little shortcut Visual Studios will do is it says, oh, this is an interface, you have to implement it, so I can drop down and say implement interface I universal remote. By clicking that accelerator, it will go ahead and create for me dummy template methods that match those method names that were defined in the interface that I can then go through and implement. Okay? So, pretty straightforward. Now, I can go back and I'm going to extend this interface one more step, and I'm going to say public string vendor. I'm sorry. There we go. So what I'm now telling I'm extending or adding to the interface, and I'm saying this interface requires these 6 methods in this one public property called vendor. Okay? Now, vendor is a string, and it's a get only, so that means that it's a read-only property. So when the implementer of the property, and if you notice this says, this kind of gave me that accelerator again because I can now implement the interface further. I'll click that and scroll down, and you'll see now it added vendor to my class. So let me collapse these real quick. And you'll notice here on vendor, it gives me a getter that throws an implementation of no implementation exception. I can override this and say return LG TV remote. Okay? Alright. Actually, one more note here. That was my mistake. None of these need to have a declaration of public. You just have to define them like this. Return type name. By default, it is assumed and required, again, that all interfaces be public. Okay? So you may be looking at this and going, okay, well, why can't I just build a base class? What's the big deal, right? I mean, it's pretty much the same kind of thing minus the implementation details. Let me build you one more class, and I'll just make it for another brand of TV. And I'll basically do the same thing. Okay. Collapse. All right. Now, if what we are creating is the implementations of that universal remote, we now need something that can kind of consume these implementations. Because think of it this way. So each one of these classes right now, the Samsung remote, the LG remote, are both specific implementations of the universal remote interface. They are the actual code that sends the RF signal to a Samsung TV and says this is power up, this is power down, this is channel up, channel down, volume up, volume down, which is very unique and specific to that vendor. We now need something that can take all of these different implementations and push them out as a universal remote. Okay? So I'm going to create one more class, and I'm going to call it the remote control. Alright. And I'm also going to implement universal remote because I'm going to have these same methods. Now, the unique thing about this implementation, and let me go back and real quick before I forget, I'm going to do... now, this isn't the best convention, but I'm going to do it for demonstration purposes. And I'm going to actually just do some real short implementations of these. So volume up, volume down. Power on. Power off. Channel up. Channel down. Now, in a real-world situation, these implementations would be different, and you'll kind of see that when I actually run it. But so what should happen here is this will say LG TV volume up, Samsung TV volume up. All right. So inside of this remote control class, that's going to be our centralized controller. It's actually what, if you think of the tangible, you have a physical universal remote in your hands. That physical remote is taught every time you push a button, it's calling a method on the firmware, and it's saying, I need you to do volume up, I need you to do volume down. So in order for it to do that, we have to be able to program it and say what kind of remotes or what types of devices is this universal remote interfacing with. So to do that, we need to have a collection of devices that this universal remote is basically projecting the RF for. So instead of coming in here and saying Samsung TV remote, Samsung TV, LG TV remote, LG TV, and then putting a constructor in and having to create an instance of each, like this is the way that you would traditionally think of doing things. And then when you got into volume up, you'd have to go through and say Samsung TV dot volume up, or LG TV dot volume up. And then if there was a new brand of TV or a new model of TV that came out, you'd have to go through and you'd have to create that class. And then you'd have to come back into here and you'd have to update this list of classes and then go through all those mechanics, which gets to be very complicated, and you have to touch every method and go through all of that work. Instead, using the interface is looked at like from this perspective, it's looked at like a base class. So it's a type. So you can declare variables of that type. You can hold instances inside of that variable. So let's kind of back up and talk about it from this perspective. So every class inside the .NET framework inherits from the base class object, right? Any class that inherits from a base class can be cast to that base class. So if I have two variables, an integer and a string, they both inherit from object. I can cast them both as object and store them in an object array, right, to house them. And then if I need to actually use them, I can cast them back to integer and string respectively, and they should be able to cast back. So that concept is called boxing and unboxing. Okay? With an interface, because we implement from that interface, anything that implements an interface can be cast to look like and act like that interface. So instead of creating two specific instance variables of a Samsung TV remote and an LG TV remote, since they both implement the iUniversal remote interface, we can create an array of iUniversal remotes, all remotes, and then inside of this constructor, I'm going to use that shorthand we learned the other week about declaring arrays quickly. We can come into here and we can say new Samsung TV remote, comma, new LG TV remote.
So you made an array of remotes, and the two remotes are the Samsung and the LG remote.
Correct. Then inside of our method, all I have to do is do a basic for loop of all remotes dot length, and then I loop through all remotes one at a time, calling volume up. So these 3 lines, basically 4 or 5 lines, will suffice. So if a new remote is created, all we have to do is add it to the declaration up here, and everything else is still kosher. And because they all implement the same interface, we know for a fact that contract requires that they all meet all of these method expectations, that they implement all these methods.
Is there really a way to get Visual Studio to use your, if you have an infrared on your computer, is it really possible to get it to?
Probably with the right drivers, yeah. You could do it. Usually it's treated as a COM port. So if you know the right, frequency and signal pattern, you could probably build your own universal remote using it.
So I had a teacher in high school who said he had fans like that were remote control in his house, and he said he made a VB app to control them.
Oh yeah, I believe it. I believe it, yeah.
I don't know if he was just crazy or...
This one will be a little different. We'll do a system.text.string builder. And what a string builder does is basically it's a dynamically loading or dynamically extending string object. So with a traditional string inside of .NET is if you do string A plus string B, you're not concatenating them together, you're actually generating a new string because they're what's called immutable. They don't shift. So with a string builder, you're actually concatenating over and over, not creating new objects constantly. So it's more efficient when you're doing a large number of object creations. So if you're ever, usually if you're concatenating like 5 or fewer strings, it's not a big deal. But then after you get above 5, a string builder actually has a big benefit. So keep that in the back of your mind. If you're in a situation where you don't know how many strings you're going to be concatenating, it's always better to go with a string builder. Alright, so that is our universal remote implementation. So if we go back to our void main, we can just create an instance of remote control. And then we can just start throwing commands at it at this point. So we can say while console.read actually we'll do a do So I'm just going to do a real quick there it is. So from here we can just say control dot volume up, volume down, channel up, channel down, power on, power off, and then exit. Alright. Okay. So we're now in our Universal Remote app. Should probably put some sort of prompt, but that's sufficient for now. So if I come in here and I say volume up 1, it then spits out Samsung TV remote, volume up, LG TV remote, volume up. Okay. If I do power on, same thing. So what's happening is it's looping through those and making those calls. But from the perspective of the app itself, this app, actually even better, the remote control, aside from these declarations, these methods know nor care anything about the specific implementations of those remotes. It's looking at it through the lens of that interface. Okay, so that's the basic mechanics. So now here's the how is this applicable? Where does this make sense to use it? I'm going to give you a few different analogies or scenarios to try to kind of paint a picture of where's the value in this. And hopefully from those and maybe some dialogue I can help you kind of understand. So let's start with a basic example, and this is where I first got the interest of what's an interface good for. All right, everybody know what Photoshop is? Photoshop? All right. Inside of Photoshop, there is a section of Photoshop, and there's actually a number of sections now, that allow you to build plugins. And the plugins for Photoshop are defined as an interface. So if you wanted to build your own application, and you wanted your application to be able to support plugins, third party somebody builds an add-on to your app, you would define an interface that would be kind of the front man, the blueprint, the contract to your plugin. Okay? So let's kind of walk through this scenario again with the Universal Remote. I could go into here and I could say add new project LG remotes. Add new project name Samsung remotes. Take my LG remote and I move it up here. Take my Samsung remote, I'll move it up here. Delete these two directly. And then from within these projects, I'll add a reference to my Week 12 app. I'll add a reference to my Week 12 app. I'll change my namespace to LG remotes. This will be Samsung remotes. Alright, so this interface, iUniversal Remote, is my blueprint for the plugins. So as a TV vendor, I want to be able to write an implementation that's compatible with this Universal Remote without giving away the keys to my kingdom and telling them how my remotes work. But I want to be compatible. I want to be able to function as a plugin for that remote. So I go out and I go out to their website, I download the SDK for building one of their Universal Remote implementations. Inside of that SDK is this interface, iUniversal Remote. I know nothing more about it except for that there is an interface that I have to implement if I want to be a supported remote by, Kevin Gantos Universal Remotes. So what I do is I, as Samsung, go out and I download this little DLL that has this interface in it. I then add it as a reference to my project. I then create a class that implements the iUniversal Remote interface. And that's it. Simple as that. LG, same thing. And actually, I'm going to have to do one more thing. Let me add one more project. I'm going to add a Universal Remote SDK. I'm going to move the Universal Remote into there. And then I'm going to... So what I'm doing is I'm trying to remove the dependencies between the different apps. So what happens is I go out and I download the SDK. The SDK is just a DLL. I'm then going to add a reference in both projects to the Universal Remote SDK. I'm then going to come in to here and also add a reference to that SDK. Let me do an F6 and clean up the compiler issues. So now my week 12 app knows nothing about LG or Samsung remotes. It knows nothing. It only knows about the Universal Remote SDK. So my goal is to be able to load these in almost dynamically. So that's the goal. Now, without going into the mechanics of how does that look and how does that feel, I'm just going to go ahead and add them as a reference. But let's assume that we had a means of loading them dynamically. If we were able to load them dynamically, I have to make these public. Let me recompile. Oh, you know what? All right. All right, so let me just kind of reiterate now that I jumped out and jumped back in. So what I've done is I have my actual application that runs, my console app. I have a class library that contains the interface, the plugin SDK. I then have two different vendors, Samsung and LG, that have both created libraries, class libraries of their own, that reference the SDK, that reference that interface, and that have created their own classes that implement iUniversal Remote. Okay? So now, and if anybody's interested, I can go through the mechanics of how to do this, but what the ideal is that this application would be smart enough to be able to go out and find any libraries that have been added as plugins and dynamically load them into the application instead of actually going in as you would traditionally do and say add reference and adding these two libraries to the project. there's actually a way by just dropping a DLL on the hard drive, you can go out, seek it, and bring it and load it into your application dynamically. And then have it comb through all the classes and find the one that implements that interface. And have the program be smart enough to do all of that work without having to bring it into Visual Studios and compile it and do all of those things. But for simplification, I'm just going to kind of include these projects. All right. So I'll bring them in. And then let me update my using statements. Okay. So I have an interface that's coming out of one DLL file. I have two different implementations coming out of two different DLL files. And then the actual application itself, which is consuming the SDK, the interface, and it's interacting with these remotes as if they're all coming from the interface only. It doesn't know about the implementations behind the scenes. It's just going to talk to them as if they're interfaces. So if we run it again, and we'll end up with the same result. Let me make one adjustment real quick. Okay. All right. So does that concept make sense? Well, yes, let me start there. That idea that you want to build a plugin. You want to be able to consume information. So another model you can maybe wrap your head around, let's go back to the Photoshop scenario, is Photoshop, just to kind of give you some context, is an application that allows you on a coordinate plane, I mean this is literally how Photoshop works, on a coordinate plane, gives you the ability to identify pixels by color. At the end of the day, that's all Photoshop is. It allows you to go into a coordinate plane and say at 0, 0, I want this to be black. I want this to be blue. I want this to be red. I mean, that's how all pictures work. It's a bitmap image, and they call it a bitmap because it's a map full of bits of different colors. So, if you wanted to build a filter that could do some sort of magic to that bitmap, how would that look? The filter or the plugin would need to have a way of reading or consuming that bitmap image, reading it in so that it can do whatever sort of voodoo it does, black box work, I like to think of it, and then it has to have the ability to then write or return that modified bitmap image back to Photoshop so that Photoshop can take it and show it to you on the screen and allow you to save it. So, in my mind, in simple terms, that means that you have to build an interface. I'm going to start a whole another SDK now.
Do you have to have an SDK for an interface? Or?
No, you don't. You can have it be built as part of your library.
But it's common if you have an SDK there.
It is common because it acts as kind of the glue between the app itself and those third-party pieces. Okay? And the next scenario I'm going to talk about is web services, and that makes a little bit more sense when I get into it. All right, so let's say that this is a Photoshop SDK. So I don't need a class file, but I do need an interface. So we need two methods. One method that is public void read bitmap, Well, we'll just do it this way. Okay, so that would be the SDK. Okay. And as far as Photoshop is concerned, Photoshop is going to have some sort of voodoo to load those plugins, and then it's going to also have a collection let me include my library. Collection of plugins. So then from here we would so it'll compile. So we'll load plugins. And then all that we would have to do is, as the application, is we would say iPlugins, or I'm sorry, underscore plugins. Well, so I'm trying to think of. So we would do some sort of console.write. And it would be the list of all available plugins. Now, if you've ever actually used Photoshop before, there's a drop down of filters. So, same concept. We're going to go and load all those plugins, list all of the possible filters that we could use, and then I, as the user, go in and I choose which filter I want to apply to my picture. So then we would load the plugin, which would be something, or we would open the plugin, quote unquote. So we would say iPlugins selected plugin equals underscore plugins I, the one that's selected, and then we'd say selected plugins read bitmap, and we'd pass in some sort of byte array. That was our image. And then on the other side of that, we would say modified bitmap would be the selected plugin write bitmap. We would then have the modified bitmap, and then we would update UI with mod bitmap. Does that make sense? That idea? So at no point do I know what that plugin does to the image. At no point do I care what that plugin does to the image. But I know that it's able to read the bitmap in and then spit me out a new bitmap that's been modified in some way. So what does the modification look like? I don't know. It could be something as simple as I feed in this picture and it turns around and prints my name in the lower right-hand corner. It doesn't have to be anything fancy. It could be as complex as going in and finding all the red eye in the picture and removing it automatically. So those plugins are custom built pieces of software that run inside your application. So the interface gives you the liberty to do that. Okay? So that's kind of, there's one scenario for an interface. So if we boil all that down, what it really means is I have something that's common. Maybe ask yourself this question as you're working on your app. I have something that's common, but there are unique instances of it that require different levels of work. So basically, maybe I have to build 5 classes to do a certain type of work. But there's a lot of commonalities across all 5 of those classes, and it'd be nice to be able to work with them as a single collection. Okay? Like I said, it's kind of abstract, so it gets a little tricky trying to wrap your head around it, but if you kind of work it, you understand it better.
What would be maybe a amount of context here?
That's all right.
It's not possible. So could you write it's because 2 weeks ago, you showed us how to do the DLL and the utility class, the connection string, and the XML behind making a connection to
Yep.
a database you made.
Yep.
Could you instead do an interface